What's up guys, welcome back to my channel, and today I'm going to show you my presentation about metallurgy steel product and properties. And so this is my profile, also there's my lecturer. So my best reference is from book Metallurgy for the Non-Metallurgists, edited by Arthur C. Reda. Classification of steel. Classification of steels from one of the most complex group of alloy is common use, and there are many ways to classify steel. Classification of steel based on chemical composition is widely used method. There are three very broad-based categories of based on composition: plain carbon steel, low alloy steel, and high alloy steel. However, it is important to point out that steels are classified in many other ways too. For example, the steel making method used such as open heart, basic oxygen process, or electric furnace method. The deoxidation practice during steel making, such as kiln, semi-kiln, capped or rimmed steel. The solidification methods such as ingot casting, continuous casting, or component or shape casting. The mill product forms such as bar, plate, sheet, strip, tubing, or structural shape. The finishing method such as hot rolling or cold rolling. The microstructure such as ferritic, pyrolytic, and martensitic. The required strength level, the heat treatment, and the last, quality description. Steel making can be broadly classified into two steps. Primary steel making is converter or furnace, and secondary steel making in a ladle. Two, the most of important steel making process are the electric arc furnace or EAF process and the basic oxygen furnace or BOF process or LD, Linz-Donowitz process. The EAF process accounts for 35% to 40% of the world's steel production, and BOF produce 55% to 60% of steel. Deoxidation practice. Oxygen is generally considered as an unsoluble element in steel because it combines with other elements to form oxide inclusions that can degrade toughness and fatigue resistance. Solidification method. After steel is melted and refined, it is then solidified into useful form by various casting methods. On a tonnage basis, most steel is now solidified in continuous casting operation, but casting of steel still involves the original method of solidifying into ingots. Product forms. Various steel product forms called mill products are produced in steel mills either by continuous casting method or by the breakdown of ingots into various growths by rolling, drawing, or extrusion operation. The various types of mill steel products include sheets and coil of low carbon steel for application ranging from cars to appliances. Wire used in such products as bed springs, wire rope, nails, and wire fabric. Structural shapes used in buildings and bridges. Last, bars for forgings and machine parts such as gear and bearings. Finishing method. The surface of steel products is influenced by its finishing method. In roll mill products, finishing by either hot rolling or cold rolling. Microstructure. Steel can be classified according to microstructure at room temperature. Heat treatment are used to produce microstructure that can consist of either perlite, martensite, or bainite, or some combination thereof. Required strength level. Purchasing standard of steel and many other materials often specify a minimum required level of strength, and some of the categories of steel are defined by their mechanical properties. Another category of steel based on strength is a group called ultra-high strength steels. These are commercial structural steel capable of a minimum yield strength of 1,380 MPa or 200 KSI. There are three types of ultra-high strength steel are medium carbon low alloy steels, medium alloy air hardening steel, high alloy hardened steels. Heat treatment. One of the primary advantage of steel is their ability to attain high strength through heat treatment while still retaining a degree of ductility. Quality description. Descriptors. Steels are described by a host of quality descriptors depending on the product and types of application. Carbon steel. All steels are iron carbon alloy with carbon content from 0.02% to less than 2%. Thus, the so-called plain carbon steels contain small amount of manganese and silicones. Carbon steels can be classified further on the basis of carbon content. Steel containing less than 0.30% C is called low carbon steel or mild steel. Steel containing between 0.20% and 0.60% C is called medium carbon steel. Steel containing more than 0.60% is C is called high carbon steel. Free matching grades. Spark pattern can be used to identify low, medium, and high carbon steel. And picture 8.3. Carbon level have a pronounced effect on properties. Picture 8.4. Carbon has limited solubility in iron and a hard carbide compound called or Fe3C called cementite form when carbon is added to iron. See chat. Alloy steel. Alloy steel contain manganese, silicon, or copper in containers greater than those for the carbon steel, or they have specified range or minimum for one or more of the other alloying elements such as nickel, chromium, molybdenum, and so forth. Sometimes alloyed steels are further defined as being either low alloy steel or high alloy steel, depending on whether total alloying content is less than 8%. This is not a hard and fast rule because some steel with alloying slightly above 8% are sometimes referred to as medium alloy steels. Ultra high strength nickel steels, high strength or low alloy or HSLA steels are designed to provide better mechanical properties and or greater resistance to atmospheric corrosion than the conventional carbon steels. They are not considered to be alloy steels in the normal sense because they are designed to meet specific mechanical properties rather than a chemical composition. The type of HSLA steels commonly used include weathering steels, controlled rolled steels, perlite reduced steels, microalloyed steels, acicular ferrite steels, dual-phase steels, and dual-phase steels. Low alloy steels constitute a category of various materials that exhibit mechanical properties superior to plain carbon steel, resulting from additions such as alloying elements as nickel, chromium, and molybdenum. High alloy steels. Steels with alloying greater than 9 with percent are typically classified as high alloy steels. Stainless steels are the major types of alloy steel, high alloy steel, but two other types are ultra high strength nickel cobalt steels and merging steels. Alloying element steels. Steels from one of the most complex group of alloys is in common use The synergistic effect of alloying element and heat treatment produce the tremendous variety of microstructure and properties. Carbon is the single most important alloy element steel. Manganese is normally present in all commercial steel. Silicon is the one of the principal dioxiders used in steel making. Copper is appreciable amounts can be detrimental to hot working operations and has a moderate tendency to cigarette. Chromium is generally added to steel to increase resistance to corrosion and oxidation, to increase hardenability, to improve high temperature strength, or to improve abrasion resistance in high carbon composition. Nickel, when used in alloy elements in constructional steels, is a very strengthener. Molybdenum, vanadium, niobium, aluminium, titanium, boron, tungsten, zirconium, calcium, cerium, lead, bismuth, nitrogen, phosphorus, sulfur, hydrogen, tin, and arsenic. Antimony. Antimony. Strength and toughness. The word steel has become synonymous with strength, and the description strong as steel in common in everyday language. Steel is usually associated with strength because in many of its use it is necessary that steels in one form or another support of a load. High strength carbon and low alloy steels have yield strength greater than 275 ampere or 40 ksi and can be more or less than divided into four classifications. First, as roller carbon managed steels. Second, as roller high strength low alloy or HSLA steels, which are also known as microalloy steels. Three, heat treatment or normalized or quiescent and tempered carbon steels. And last, heat treatment low alloy steels. Toughness steels are generally considered though materials that is they can absorb the energy of an impact without breaking. Axle shaft and steering component of an automobile are examples of application requiring toughness because fracture of these components during surface would be life-threatening. Fatigue strength: when a steel component is subject to repeat or cyclic stress, including vibratory stress, the part can fail by fatigue. Even though the bolt stress level acting on the parts may be below the yield strength of the steel, the most effective and economical method are improving fatigue strength. Involve designing the part to eliminate stress races, avoid sharp surface tears or indentation that may result from punching, stamping, shearing, and even hardness testing, preventing the development of surface discontinuities or decarburation or loss of carbon the steel at a surface by reaction with the furnace atmosphere during processing or heat treatment improving surface finishes. Elevated temperature strength. Carbon steel and alloy steel with varied pearlite or varied bainite microstructure are used extensively at elevated temperature in fossil fuel-fired power generating plants, aircraft power plants, chemical processing plants, and petroleum processing plants. Many applications, however, are more familiar. And last, corrosion. The word corrode is derived from the Latin corrode, which means to gnaw to pieces. Corrosion takes on many forms, can be divided in many ways. For the purpose presented here, the metallurgical definition of corrosion is an electrochemical process whereby metal atoms exchange electrons with atom in envelope. So guys, thank you for watching my video and sorry for the misunderstanding words. See you on the next video. Bye.